In this example, we are going to think about the derivative of a function, but in this case, we're going to think about it evaluated at a point, and from maybe the opposite perspective. We're going to think about working with that difference quotient. So the first question asks, the limit given here is going to represent the derivative of a function at a point. And the question that we want to answer is simply, what function and what point? That is, we don't actually want to evaluate this limit, we just want to know this limit represents what derivative in a sense. So let's kind of start off with the reminder. As a function, we define the derivative to be the limit as h approaches 0 of f of x plus h minus f of x all over h. But we can also think of taking a function and evaluating it at a point. So if we had a point C and we wanted to know what is f prime of C, this would be the limit as h approaches 0 of f of c plus h minus f of c over h. And what we would like to do is compare this quantity in the numerator, the f of c plus h minus f of c, with the 4 plus h squared minus 16, and see, can we determine which function we are dealing with at what point? So looking at just the first terms, our f of c plus h is represented by the function 4 plus h quantity squared. So what that tells me is we are taking the expression c plus h and we're plugging it into something, where in this case c is going to be 4, and the function that we are plugging into appears to be the function that just takes that 4 plus h and squares it. So making that connection, the function that we have is x squared, and we are calculating the derivative at the point c equals 4. Now, another way to see that that point c should be 4 is to look at the second term. We're subtracting away 16, and 16 is representing f of c. So for the function x squared, f of 4 is 4 squared, which is 16. So f of 4 plus h minus f of 4 over h. So that is the derivative of the function x squared at 4. So a very similar problem. What we would like to do is compare here to the difference quotient and determine what is the function we are taking the derivative of and at which point. So once again, if we look at the first term in the numerator, because we're taking the limit of a difference quotient, so f of c plus h is represented by the square root of 16 plus h. So the c plus h that we're plugging into the function is going to be represented by the 16 plus h. So it appears that the c is equal to 16, which is something we're going to check, and that 16 plus h is plugged into the function square root x. So f of x equals the square root of x, and the value 4 that we're subtracting away, this needs to be the function value f of c. So if f of x equals the square root of x, f of 16 is the square root of 16, which is equal to 4. So we have the function square root x, and the limit above represents the derivative of that function at the number 16.